investor. 16T24 is my roll number. Today we will discuss the second part of regression digital filters. Now moving on to my lecture, last continued lecture. In this lecture we will state the first way to implement a digital filter is by convolving the input signal with the digital filter impulse response. All possible linear filters can be made in this manner. So when the impulse response is used in this way, the filter designers give it a special name, the special kernel. There is another way to implement a digital filter. This is called recursion. When a filter is implemented by convolution, each sample in the output is calculated by weighting the samples in the input and then adding them together. Recursive filters are an extension of this, using previously calculated values from an input besides point from the input instead of recursion methods. So now there is another factors that involved in this sector is recursive filters are also infinite impulse responses, while in comparison filters carried out by convolution are finite impulse response (FIR) filters. Now moving on, there is another term how to calculate something and how to present something in terms of decibel. Then it's way the power divided by power 1 of power of signal 2 divided by power of signal 1 in 10 log 10 can be turned into the decibel, and same goes for the amplitude. When if we 20 log 10 of A2 by A1 will give us the value in AB and dB if you want to wish for it. Now how information is represented in signals? There are many ways to represent information, but luckily and fortunately only two ways have to be represented: naturally occurring signal for naturally information presented in the time domain and information represented in time domain. So there are two ways basically to represent any signal, which are information represented in time domain, information represented in frequency domain. So how we present information in time domain? When something occurs, what amplitude and how recurring, what were the amplitude when something occurs, and what, like suppose if I imagine an experiment to study the light output from the sun. The light output is measured and recorded once in each second. Each sample in the signal audio, what is happening at what instant and what level. If a solar flare occurs, the signal directly provides information on the time it occurs and the duration, the development over time. Each sample contains information that is interpretable without reference to any other signal. Even if you have only one sample from this signal, you will still know something about what in occur. While in contrast, information represented in the frequency domain is more indirect. Many things in our universe show how periodic information. The pendulum of a grandfather, clock swings back and forth, stars and planets rotate on their axis and revolve around each other, and so forth. By meaning the frequency, phase, and amplitude of the periodic motion, information can be represented in much way. So now